Hey, this is Mr. Ward. I'm going to do a video on some of the problems that I've assigned for Chapter 8, Section 5, and a word about how to use a video about the problems. Now, it might be tempting to just go through and do the problems with me, and if you're really struggling with this, that might be the best thing to do. However, you will get more out of a video about working the problems if you pause the video whenever I'm about to talk through a problem and you try it yourself. And then you can start the video again and see how I'm approaching it and compare your approach. You may have a different approach that still works. There are many paths to victory with this stuff, but you will get more out of it with an active engagement approach than sitting back and letting me tell you how to do things. So that's how you'll learn a lot better. That's how things work in general. But I'm going to go ahead and start talking about this. So let's talk about number 1, because you have to do 1, 2, or 3, 4 or 5, 6, 7, 14, 15, 16, 21, and 29. As you might be able to tell, this is somewhat of an important section. So I've got BE is parallel to CD, and I've got the links as shown. So I got this 6, this 3, this 5, this 4, and of course, 3 and 4 make a 7. So I know the full length of that side. I need to find ED, and I need to find CD. Now, ED is going to just require me to deal with the 6, 3, and the 4. CD will require me to have figured out that AC is 7. So I'm going to be, so for ED, I'm just going to say 3 is to 4 as 6 is to what ED is. And so that's just fairly straightforward. 3 is to 4 as 6 is to 8, of course. Now, for this one, we're doing 3 is to 7 as 5 is to CD. So 3 is to 7 as 5 is to CD. I think it might be useful to write that down. So 3 is to 7 as 5 is to CD. And so we're going to get a fraction for this one. So 7 times 5 will be 35. So that'll be 3 times CD equals 7 times 5. And then we can work out what CD is from that. I'll let you do the rest of the arithmetic on that one. And now I'm going to go ahead and take a look at 2 and 3. So 2 and 3 are using the same stuff. This is all, of course, going back to this theorem 57 about parallel lines to the parallel line cut of a triangle is parallel to the base of the triangle, divides the sides into proportions. Okay, so let's take a look here on 2. So we're trying to solve for x and y as shown. So we've been given some information. For x, we're going to have to do 5 is to 3 is 10 is to x. That should be fairly straightforward. X is going to be 10 is double 5, so x will be double 3. So you can mental math that that's going to be 6. Y is going to require a little bit more work because it's going to be 9 is to y as 5 is to 5 plus 3. So 5 plus 3 is going to be 8. So 9 is to y as 5 is to 8. So we're going to want to set up a proportion for that one. So y, I'll say, I'm going to do it upside down. So y is to 9 as 8 is to 5. Okay, this is the 5. 5 plus 3 is the 8. 9 and y. So I'm going big to small, big to small. And then you would simply get the cross products. The product of the means is going to equal the product of the extremes. So 5y will equal 9 times 8. And I'll let you do the arithmetic for that one as well. Now I'm going to grab the eraser and clear some of this stuff out. I imagine you have the technology to go back in time and see what I said before I erased it. So you will be fine. Now we're going to solve for P and Q as shown. So it's going to be similar stuff. P is to 2 as 6 is to 4. So P should be half of 6, so P should be 3. And Q is to 15 as 6 is to 6 plus 10. So Q is going to be to 15 as 6 is to 10. Okay, so we can set that proportion up nicely. We just have to write it all out. So Q is to 15 as 6 is to 10. Okay, and then that makes a proportion. So 10Q will equal 15 times 6. So you'll be able to find out what Q is. Fairly straightforward proportion problem. I'll leave that to you to do. Okay, let's take a look at 4 and 5 because you got a choice of 4 or 5. Scroll down a little bit so they're more front and center. Oh, look at what happened to my little drawing. It got stuck there. Fascinating. I'm just going to pause and erase. It's weird. Sometimes the drawings travel with the picture, and every once in a while there's some weird way in which, oh, see, now it's showing up again. I'm going to pause one more time and erase. I assume there's some sort of frame that the drawing is getting stuck in. So here we're going to be dealing with, I think it's Theorem 58. So scroll up. This is the ones where you've got multiple parallel lines, and you've got them going through 2 or more transversals. And so they divide the transversals into proportional segments. So we know A, B, C, and D are parallel. We know KP is 15, and we've been given some links for F, G, GN, and NJ. We're asked about KM, MO, and OP. So we really just want to see how big all these little pieces are. Well, to do that, you're going to need to know what FJ is because we know KP is 15. So you're going to be doing 2 is to what FJ is as KM is to 15. And then you'll do 3 as to FJ as MO is to 15 and so forth. So we can figure out pretty quickly that FJ is 2 plus 3 plus 4. So that's going to be 9. Okay. So we're going to be doing 2 is to 9 this will be for finding out KM. 2 is to 9 as KM is to 15 because KP is 15. And you'll do the same kind of thing for MO. You'll use 3 instead of 2. OP, you'll use 4 instead of 2. And all of those will be solvable like that. In this one, we're supposed to find X in this diagram. So 10 is to 5 is 2 is to X because these lines are all parallel. So 10 is to 5 is 2 is to X. So X has got to be 1. All right. I'm going to clear those drawings. I'm going to pause the video and clear that, erase that. And by the magic of video editing, I have deleted that drawing. So now we're going to look at numbers 6, 7, and 14, 15, and so forth. So let's see 6. So 6, we've been given that RVS is the same as SVT. Those angles are the same, which means SV is an angle bisector. And by Theorem 59, the angle bisector theorem, oh, that's really fascinating. That's still there. Okay. Go back up here to the angle bisector theorem. There it is. BC is to CD as AB is to AD. Basically, it divides the base into segments that have the same proportional relationship as the sides of the triangle. So let's go down there and see. So that means that RS is to ST as RV is to TV. So we can very easily solve that. And the next one's going to have a similar situation because it's already given us the 2 angles. Okay, and so 4 is to 6 is 6 is to X. Okay, so you can solve that. I will go ahead and write the proportion for this one. I'm going to go ST is to 6. I could organize this in a variety of orders, as 8 is to 12. Okay. And you can probably very quickly see that ST has to be 4. On this one, we're going to have X is to 6 as 6 is to 4. Oh my goodness, we've got a mean proportional. So that's going to make a 36, and that's going to be x times 4. So x is going to have to be 9 in this case, because 36 divided by 4 will equal 9. Okay, let's keep going to number 14. Number 14 looks tricky, but it's not as tricky as it looks. So we know angle 1 and angle 2 are congruent. And so what that's actually telling us is that these must be alternate interior angles for a transversal going through two parallel lines. So OK and PG must be parallel. And so we're trying to prove that KM is to JK as MO is to OP. Well, Theorem 57 established that if you use a parallel, so you just have to prove that OK is parallel to PJ, and then you'll be able to use Theorem 57 to work this one out. Because Theorem 57 says that if you make a parallel line to the base of a triangle, so you divide a triangle up by doing that, you divide the triangle into the legs of the triangle into proportional segments. So MO and OP and MK and K and JK will be proportional segments, but you got to prove that. You got to walk through the proof and talk it through. Now, number 15, we're given angle 3 is congruent to angle 5, but you may notice that angle 3 is a vertical angle to angle 4, which means that if angle 3 is congruent to angle 5 has to be congruent to angle 4 by the transitive property. And that means that VS is an angle bisector. So angle bisector theorem for the win, and that's Theorem 59 up above. So that tells us that that'll help us know that RV is to VT as RS is to ST. And you'll be able to prove that pretty handily. Now let's take a look at 16. At a trapezoid. When they told you it's a trapezoid, that tells you that XB and YZ, so WYZB, and it's got bases of WB and YZ. That's telling you that WB and YZ are parallel as one of the characteristics of a trapezoid. Its bases are parallel. We also know that XA is parallel to YZ. So now we have 3 parallel lines because now XA is also parallel to WB by the transitive property. Okay, so we want to prove that WX is to XY as WC is to CZ as BA is to AZ. And that's fairly straightforward because WY, WZ, and BZ are all transversals cutting through 3 parallel lines, and 2 and 3 or more parallel lines will divide transversals that go through them into proportional segments. So I'll leave that to you to prove and talk through, but that's the basic idea. 21. 21, we know that angle 1 and angle 4 are congruent. And we're told that AC is perpendicular to BE. Well, that means that angle ABE and angle CBE are right angles. So these two congruent angles, 1 and 4, they each have an angle that has to be complementary to them. So 2 is complementary to 1, 3 is complementary to 4, and if you're complementary to 2 congruent angles, you're congruent. So that means BE is an angle bisector. And if angle B in line BE being an angle bisector divides the base of this triangle into segments, into proportional segments, so DE is to EF, as BD is to BF, and I'll let you walk through the proof of that. 29. Okay, 29. Suppose that Theorem 56 and Theorem 59, okay, this Theorem 56 is side angle side similarity. That's where you have 2 sides, corresponding sides that form proportions in 2 triangles, and an included congruent angle. Okay, and then Theorem 57, if a line is parallel to one side of a triangle and intersects the other 2 sides, divides them proportionally. So let's assume they were postulates. Suppose they were postulates. We're going to use that to prove that AA is true. Okay, so angle A, we're given angle A is congruent to angle D. We're given angle B is congruent to angle E. And we need to prove that ABC is congruent to DEF, or similar to DEF. And there's some suggestions, key steps of a proof. Introduce R and S such that AR equals DE and AS equals DF. Okay, so let's see what that means. So down here we've got R and S. Okay. And R and S, so we're saying that R and S, so that AR would be, basically we're taking DEF and we're plopping it onto this triangle here. So we're moving this triangle over here and we're just laying it on top of here. So DEF is essentially being set up to be congruent to ARS. ARS is created as a copy of DEF. Okay, so here's some things from the postulate that is actually a theorem. So RS is going to be parallel to BC. Okay, and AR is to AB as AS is to AC. Now, that tells us that ARS is similar to ABC. But ARS is congruent to DEF, and so then we can just use the transitive property to say that if ARS is similar to ABC, then DEF is also similar to ABC. And that's pretty much all there is to do it, and I hope that was helpful.